Computing within limits is a research field that investigates how computing can operate sustainably within planetary, ecological, and resource boundaries. It challenges the assumption that current trajectories of ever-increasing production and consumption will continue indefinitely, recognizing that humanity faces fundamental planetary constraints related to climate systems, materials, and biocapacity. A practical example of computing within limits is found in low-power hardware design. Engineers are creating devices that meet essential computing needs while minimizing energy consumption. These systems prioritize longevity, repairability, and minimal resource use over processing power or feature growth. For instance, some organizations develop modular computers where individual components can be replaced rather than discarding entire devices, extending useful lifespans while reducing electronic waste and raw material extraction requirements. Computing within limits connects to several critical areas. It aligns with efforts to create sustainable infrastructure that prioritizes long-term ecological balance over short-term productivity gains. It directly addresses issues of material scarcity by rethinking how we design, manufacture, and dispose of electronics. Most importantly, it questions the default assumption in most computing research that ongoing economic growth is both achievable and desirable. Recognizing that this worldview conflicts with evidence from many scientific fields showing planetary boundaries that must not be crossed. The concept of computing within limits can be seen in distributed resilient networks designed to function with intermittent power or connectivity. These systems distribute computational loads across many nodes, allowing for graceful degradation rather than complete failure when resources become constrained. Unlike centralized systems that require constant, reliable power and connectivity, these networks can adapt to changing conditions by reallocating resources based on priority. This approach demonstrates how technology can be designed to operate effectively within resource constraints rather than assuming conditions of abundance. Computing within limits intersects with several technology-focused areas that question dominant paradigms of continuous growth. For instance, it connects to research in appropriate technology, which develops solutions tailored to specific environmental and social contexts, rather than assuming one-size-fits-all approaches. It relates to degrowth computing, which explicitly designs systems that reduce overall resource consumption while maintaining essential functions. Additionally, it explores disintermediation, removing unnecessary technological complexity that consumes resources without providing proportionate benefits. These technological approaches recognize that limitless expansion is neither possible nor desirable on a finite planet with ecological boundaries that cannot be transgressed.